Okay, now that we have seen the turboprop and other engines, we are now going to shift to turboshaft engine. Turboshaft engine is also is a variant of a turbojet engine. The working principle and the components majorly are same. It also works on the Brayton cycle. So the turboshaft engine, it is optimized to produce the shaft power rather than just jet thrust. So we'll take a look at the components first. So as shown in the diagram, we can see the rotor and the output shaft. There is an inlet, there is a compressor, and there are turbine of the both variants, and there is also a combustor. So to understand the turboshaft engine, we need to get that there are two major components. The engine is divided into two major components. The first one is gas generator and the second one is power section. So the gas generator section is going to contain the compressor, the combustion chamber, and the power section is going to contain the free turbines and a gearbox. Okay, so now let's understand the working of the turboshaft engine. So the first stage is intake and compression. So the air, the atmospheric air is drawn in and it is compressed to a very high temperature and pressure in the compressor. Then we have the combustion. In the combustion chamber, when the air is drawn, the fuel is ejected simultaneously into the chamber, and the compressed air is compressed, and the temperature and the pressure of this air is going to change very drastically. Next we have gas generator stage. So the high energy gas, it drives the gas generator turbine which is present. It is a free turbine which in turn it powers the compressor, which makes the process very self-sustaining. Then we have the power extraction, how the power is extracted. So the hot gases which expand through the free power turbine, because the power turbine is not linked to the compressor with any shaft. It rotates at a speed of very high RPM, and it is very optimal for the loads, for example constant rotor speed. While the gas generator, it runs at a very low, or as we can say, an optimal speed. Now let's talk about the power transfer. So the torque which is generated by the power turbine, it is transmitted to the reduction gearbox. The reduction gearbox is a very important and a crucial part, because the turbine blades are rotating at a very high RPM, and to reduce the speed, we need a gearbox which drives the rotor or the output flow. So basically it works by compressing air, mixing it with the fuel, then combusting it to drive the free turbine which are present, and at the last we have a gearbox to reduce the speed of the rotor blades.